Hey guys, and welcome to the show. I am out here in the middle of the Mojave Desert, and it is cold and windy. I'm surrounded by technology that at one point was state-of-the-art, but now is pretty much obsolete. So today we're going to talk to Norm Judah about the future of technology. Sit back, relax, and enjoy the show. Hey guys, and welcome to the show. I am smiling and laughing because this is absolutely my favorite show of the year. We've done it every year now for the last 4 years. And I am, of course, talking about our Future Technologies show. And that means our special guest today is none other than Norm Judah. Norm, how you doing?
I am doing great, and happy 4th birthday to you.
Yeah, thank you. Yeah, absolutely. You know, we've been doing this show for a long time, and
Yep.
and when we started it, we just, you know, it was just like something to do. I had been listening to some CNET podcasts that I really liked, and they took them off the air, and literally within weeks, you know, I'd been thinking to myself, well, I could do that. You know, I don't know. I'm going to miss that show. Chris called me. He's our producer, and said, hey, you know, would you like to be a guest on so-and-so show? So we did it. And then I called Chris back and said, hey, let's do our own show.
Yeah.
And that's how it started.
So last year was the number 100, if I remember. So we've done a lot of these.
Yeah, absolutely. Yeah, we do 2 a month.
Yep.
So 24 a year. And I think now we're actually in our 5th year.
Yep. Cool.
Yeah, we brought you in at the end of the first year.
Right. I remember that. Cool.
Yeah. So things have changed a little bit.
Always.
I don't have my instrumented park bench yet that orders pizza for me.
It's coming.
Yeah, but I figure it's in the mail. Amazon's gonna deliver it by drone.
Now why they could just deliver the pizza by drone? They don't have to deliver the bench.
There you go.
You just got to think pizza, and then this drone will arrive. Yeah,
absolutely. And so I was thinking about stuff for us to talk about today, and pre-show we talked a little bit about it as well. You know, and AI is kind of the first thing that came to my mind, and not scary AI, right? There's an issue, I think, in public perception of AI, because, you know, when you talk to somebody about AI, you just know they're thinking about the Will Smith movie with the robots.
iRobot, yep.
Yeah, iRobot, that's right, yeah. And it's not like that really at all. Cortana would be an example of AI, right?
Yeah. Well, there's actually some amazing examples. Let's go back to that movie a little bit, because it's not the movie that's interesting, but the book that came before it. So that's written by Isaac Asimov as a series of essays written in the 1940s that was assembled into this book published as iRobot that talks about robots going wrong. And one of the things that he does is he comes up with these laws of robotics, the sort of basic laws: robots won't harm a human, robots won't harm another robot, and so on. But what he does, though, is he projects the time frame for that as actually being 100 years from the day from when he published in 1948. So he publishes that as if it's in 2048. And the interesting perspective is we're there today. We were there yesterday, where these issues are coming up about autonomous behavior in cars, in airplanes, in boats. That actually, the thing he was wrong about was not the problem, but the timing is actually much sooner than he predicted.
Yeah.
That's just the amazing thing.
Yeah. Yeah. And there's all sorts of news about self-driving cars, all sorts of stuff like that.
Yeah, most of it bad news. The bad news hits the press quickly. The good news actually is sort of fairly silent. But what I think you're seeing is the sort of early days of that experimentation, and there's lots of different people experimenting around the world. It's not just happening here, but around the world experimenting broadly with autonomous driving. But getting to this notion of good AI and bad, or big AI and small, there's really sort of two kinds: closed loop and open loop. And autonomous driving, drone delivery or cars, is closed loop, where the AI system is making all of the decisions. The place where we're being very successful today is on open loop, which is AI system saying, I recommend you do the following. The difference between that and closed loop is when the car says, I recommend you do something, the car does it. But here's one of the interesting things we're discovering that I think is going to either slow this down or speed it up, which is the ability of humans to deal with a recommendation with a probability. So the autonomous car comes up and says, there's 72% I think I'm going to hit a bicycle. What should we do? And the driver has to decide what they're going to do. The problem is with most people, as a human, when you see that number 72, you say actually equals 100. And people take the action as if it's on the 100 and don't really have the right understanding of probability, which was, no, there's 28% it won't happen. And so you have to make a judgment on whether you think that 72 is likely or the 28 is likely. Most people don't think that way. When they see a recommendation come out of an AI system, it's like 100%, go for it. And it's not. It's about probability. And the whole thing about machine learning models is that they're assessing the most likely outcome.
Right.
But what they don't convey to you today is the probability of the outcome. And that's, I think, going to be one of the interesting things that are going to happen in the coming years is the ability of people to absorb a recommendation like that and take action or not take action in either way.
It would be an interesting study to see what type of personality takes which action.
Yes, definitely. So there's a quick pop-up that says, can you tell me whether you're actually or whether you're crazy or not when you actually take this action?
Yeah, so I was just thinking, my wife would say, oh, 72%? That's definitely, we're going to hit it.
Yes.
I would look at that and say,
maybe not.
So what you're saying is there's a chance.
Yes. Yeah, exactly. Maybe not.
Yeah.
Maybe not.
Yeah, pretty funny. One of the things you mentioned was big AI and small AI.
Yeah.
Can you tell us a little bit? I haven't heard those terms before, so I'd like to understand what the differences are.
So it's a kind of a term that we created because when you talk about AI solutions today, people tend to think of massive predictive maintenance solutions or autonomous cars that are very complex solutions that when you actually look at the time frame to execute, it actually is a long time. They're complex models. In fact, they're, in most cases, models that need to be built from scratch because there's no understanding of them. And some of them are successful, some are not, but you don't really know the outcome until you've waited a long time. They tend to be expensive to build and just expensive to maintain. The side note on the maintain part, remember that machine learning models are organic, and the more you use them, the more they change because machine learning models learn. That's what they do. And so you can teach them up front, but the more data you give them, the more they learn. And so over time, the outcome might actually change. Small AI is some simple things that you can do with cognitive services to get a quick result and actually add value quickly. Let me give you a little example. We're doing some work with a Danish company that does bridge maintenance, which sounds really boring, but if you actually think about what does it take to maintain a bridge? Well, yeah. You got to send an engineer out. Well, you probably want to close down a lane on this bridge when you send the engineer out to inspect the bridge. So you've got to orchestrate all of this movement of shutting down a lane of the bridge, and he walks out with a camera and takes photographs of the bridge and then comes back to his office, sits down at a workstation and inspects each picture one by one. That's sort of the manual way of doing it. The way I would have done it yesterday, I said, no need to walk. I'm just going to fly a drone down the bridge, bring back the footage, and then I'm going to sit on my workstation and look at the drone footage. So I'm a lot better because I haven't had to shut down lanes and it's not as dangerous, and I'm getting back good data, but I've got 20 minutes of video data that's actually fairly detailed to go through frame by frame. But we can do better than that. So what we did with this company is we took the drone footage and we got a guy who understands
Wait, hold on. So we actually did this.
This is real. It's real. I can show you the slides. This is real.
Wow. Okay, go ahead.
What we did is we took the drone footage and we found 87 still images from the drone footage, each one about a 4K image. We carved it up into snippets, 3x3 snippets, and then we had the same engineer who was walking the bridge now go through and label the data, saying this is rust, this is a crack, this is algae. And from the 87 images, we landed up with about 1,100 labels of failure. That was used to program the model. So now we've got a trained model, and then we take the complete video footage, run it through, and it comes back and actually finds all the cracks for us because we've trained it. And we actually trained it on non-failures as well. You can say, this is not a crack versus this is a crack. So about 1,100 pictures to train it. The video takes a couple of minutes to run through, and then I set it a Power BI dashboard, and I can double-click onto all the places that the model identified a crack. And so it's not perfect, which is actually the sort of small part. It's not perfect, but it actually will give to the engineer in his workbench a sort of sequence of all of these cracks that he can now inspect. So he didn't have to walk the bridge. We flew the drone, and he doesn't have to walk the whole video. He can just look at the individual cracks. Probability, again, is not perfect. It actually says, look, I think we caught most of them. I think this is a 72% probability of a crack, and the engineer can look at it and say, yep, it's a crack, in which case he trains the model again. The question is, how long did that take? Because if I said you do predictive maintenance on Rolls-Royce jet engines, which is something we talked about previously, that took about a year to do that whole project. In this case, including building the Power App, the Power BI dashboard, getting the drone footage, took 4 weeks. So now we actually can take cognitive services and build really useful little applications. But that engineer loves us now because his world has changed. Because now he actually is super efficient. He's sitting at a workstation. He's actually navigating through, just looking at these pictures. And from there, he can say, what's the work plan of how are we going to fix the bridge? Now, there's a more interesting thing that if we go future a little bit. There's a great piece of technology that we've got to autonomously train the drones. Now you're getting to more complex stuff, which was, wouldn't it be great if I could send a command to the drone that says, go film the bridge? To do that today, I've got to feed it a set of GPS coordinates that the drone flies down a known path, coordinate A to B, B to C, and so on. But wouldn't it be great if I could say to the drone, follow the power lines or follow the bridge? And so great technology that came out of Microsoft Research called AirSim that allows us to build that model in a simulated way. We actually run a series of simulations of the drone flying that trains the drone model. And then the command is, go take a picture of the bridge and send it to me when you're done to the drone. And the drone goes off and does this little thing.
Wow.
So that's now much more complicated. But the little app that I talked to you about is sort of super interesting because that's now giving us a lens into a problem, excuse the pun, where an engineer, we're actually optimizing his time, but we're also using him as an expert. We're using him to label the data that says, this is a crack, this is rust, this is not a crack. So that's what I mean by small AI. It's the notion of actually small wins and doing it quickly with the tools that you've got today. And so I sort of separate those two out because one of them, the sort of complex predictive maintenance, is very different from video inspection or looking for fault on a production line. If you've got a bunch of boxes moving on a production line, you want to identify something that's wrong. Or we've done a project with one of the electronics assemblers in Florida looking at doing a visual inspection of a circuit board. And if you know those things, those boards move kind of quickly, and we can actually detect whether there's a resistor missing or if it's misplaced even at the wrong angle. And you can do that in a little app. And so we're trying to get people through this idea that AI is hard, it's complicated, and it takes experts. You can actually do this stuff really quickly. So that's the notion of big AI and small AI.
Going back to the bridge model, that's actually really interesting, right? Because there are lots of different types of bridges. So I imagine that it would be, not easy, but relatively easy to get the drone to identify cracks in a specific type of material or a specific structure.
Yeah.
But then you've got steel bridges, concrete bridges, wooden bridges. You've got all sorts of stuff.
Actually, it's even more interesting than that because I had a meeting and I told this story to a company the other day, which is a company that does wind turbines. And in this case, their wind turbines, the farm is actually out at sea. And because there's a lot of wind, it's super effective. So for them to do maintenance, they got to send a boat and a crew out. So they pack these guys up. They put their lunch and the equipment on the boat. They sail out. They get out there. They do the inspection. They discover they don't have the spare part. Back to the shore. Back again. Got to go get the piece. Now they got taking dinner because they'd had lunch. And now they're back on the boat again. And they're out there. So if we can take a drone to actually fly around the windmill and identify potential failures, if you can save one boat trip, what's that worth?
Oh, yeah. Yeah, it's just nuts. And it's really cool, the combination of these technologies, like drone technology, right?
Yeah.
Couldn't have a drone without computers controlling those motors.
Nope.
And then taking that data and feeding it through an AI engine that produces a result. That's just awesome.
Well, some of the drones themselves have some pretty good navigation. The more modern drones, you can actually say, follow me as the command. And then wherever you walk, wherever you're doing, maybe you're in a kayak, the drone will kind of follow you. That's AI in a sort of a microcosm navigating doing autopilot, sort of following you like a guided missile. Those drones are pretty smart. We showed something at Build the other day when we did the conference in Seattle that was kind of cute, which was there was an obstacle course that's set up, and the problem was for the drone to identify and find a particular object on the floor and do it autonomously, no direction. The command was go find, and I think it was a pink unicorn or something like that. And the way that this worked was folks would build the model in the cloud, train it in the cloud, and then take the executing model, put it into a container, download it to the drone, and then and so they had this drone competition where people would download their model and then the drone would run around, and the question was, how long would it take for your drone to find the pink unicorn? That's something, if you think about that, that was something we couldn't even thought about years ago. I mean, I remember playing as a kid with radio-controlled airplanes. It was this rocket science. You'd have to have this professional guy with you, crash a plane or two in the process. Now it's just you take the drone and you stand up your phone and say go up, down, sideways, and it just does it. So that level of sophistication has happened like really quickly.
Oh yeah, yeah, and it's only the speed is only going to increase.
I think so.
Yeah, the speed of innovation is only going to increase. I mean, I give Disney 10 years before some kid walks in and says, yeah, those animatronics are cool, but I've got one at home.
Exactly. Let me show you. It's actually in my back pocket.
Yeah, it's here you go. Or just put these glasses on. I can tell you everything you need to know about whatever that subject is.
But if you actually think about the rate of change of drones, an important aspect of that was, if you go back to my radio-controlled plane thing, out in Seattle over here, there's actually 2 radio-controlled aerodromes, which is where the Boeing engineers go who've been building planes for 25 years, and then they retire and build these beautiful radio-controlled things. There was a guy who had a Lancaster bomber from the Second World War with 8 engines. They're just beautiful. He doesn't really fly them because they'd hate to crash them. But radio control at that time was a specialized things for nerds. It was something that people who really were dedicated, who had a lot of money to burn to build these models and break them. Now, when you look at a drone, you can go into any toy store and buy a drone for $25, a little drone, or you could spend $1,000 on a fancy one. But it's commoditized that technology. Lots of people have got drones today who are not nearly experts. They using it for photography, film a house being built or something. It's completely changed the way people think about the sort of autonomous nature of vehicles.
Yeah. Yeah. Do you think we will see passenger drones at some point?
Actually, there was a news article here locally because Boeing is invested in a company that's doing electric planes.
Yeah.
And they've actually got this electric plane, kind of a Tesla in the sky. Once you've got those pieces, you've got the electric infrastructure, the fly-by-wire in the plane, pretty quick to actually go to autonomous passengers. Not autonomous drones like the sort of military things, but autonomous passenger drones. But we've done some interesting projects with some boat companies because an autonomous boat's actually pretty hard to do as opposed to an autonomous flying drone. Given the sea and the weather conditions, I mean, anybody who's a sailor knows that it's non-trivial sailing a boat. And so the idea of autonomous boats, planes, trains is kind of there. You see them in the vacuum cleaners in your house doing stuff, but then again, the vacuum cleaners are not that intelligent. They can actually have a map of your house, but if there's something in the way, they don't necessarily know how to deal with it. They don't know. Right. They kind of try to avoid it.
Most of them have some sort of, bumper or sensor that's physical that detects an object.
Yes, sometimes they can see it and sometimes they touch it. But they can't do anything with the object. They sort of go around it and try and feel it. But most of those things in your house, when they run around, actually form a map of your house or your apartment, wherever you are. And so they're storing a physical map that they know where things are. But if you want to mess with one of them, move the chairs around. Take your dining room table or a sofa and put it in the middle of the room, and they get super confused because the map that they've got says there's nothing here. And then when they discover it, they've got to rediscover the room. So they actually re-navigate the room to figure out where everything is.
So what I'm hearing is you're pranking your vacuum cleaner again.
Exactly. You're messing with it.
Yeah. So the real question that I want to, and I'm asking this for a friend, is if my digital assistant knows everything about me, can it plead the fifth?
Well, it depends on how much it understands about your personality, because if it really knows your personality, it should know when you would plead the fifth. as opposed to when you would leak the information out.
Yeah, that's funny. Okay, so that's awesome. Let's talk a little bit about AR and where we're going with AR, because I know everybody's seen the original HoloLens demos. You know,
Right.
what was that, 3 years ago, 5 years ago?
Yeah, 3. Yeah.
Yeah, where, you know, the plumber circles the little,
Right.
you know, elbow pipe on the surface, and it shows up in the person's
face,
HoloLens. Yeah.
So it's been sort of interesting because you saw a massive injection of technology, both things like HoloLens, and there's been nothing like HoloLens. It's still sort of a unicorn in capability, but a lot of VR on your phone, VR on a different kind of headset, to actually get people used to the notion of dealing with this virtual reality. Pokemon Go changed the whole world because suddenly you had amazing people walking around looking at their phones in the middle of a park, trying to find characters. And so there was this acceleration of the understanding, but frankly it kind of stalled because that Pokemon Go got kind of old for a while and lots of people did it, but I don't see that many people doing it today.
Right.
You do see sort of special instances of it happening in a store or something like that where it's actually happening. But what we've seen is a lot of success in the commercial space and less so the consumer space, I think, as a price point. But you know, sort of special gaming where you're actually seeing VR gaming, you're seeing some work being done there, and gamers, it seems, have lots of money to spend on gaming equipment, and so you're seeing that being spent there. But the real success of AR VR has actually been in commercial, which is a lot of real commercial applications written like that. There's one we did in Dubai with the Dubai Water Authority that in their control center, the controllers actually wear this HoloLens so they can actually see the operation of the control center in sort of real life form, but with real life telemetry. So it's the IoT telemetry coming into the VR rather than just seeing a 3D diagram redrawn. And so you're seeing these sort of live elements being implemented. The flip side of it is the sort of remote assistance scenario you described, which is a remote expert looking in. That's been generalized because it turns out we've seen one for elevators, we've seen one for plumbing, but there's a generalizable model that says, as the person close to where the issue is, I want to be able to have an inspect what it is. I want to be able to see plans, as-built plans of what it looks like. I want to go back into previous service history. And so there was just some stuff that was announced from SharePoint, which says if I wear a HoloLens, I can actually look at the SharePoint and put those documents into the free space around me. So I can look down and do my work, but I can also look up at a plan. I could look at service history. I can look at a part description. And that's totally generic. The thing that they've done is they've also put a Teams interface into it so that I can actually look up along a Teams thread. I can navigate the thread, but I can also make a Teams call. So I can call somebody in to do it. And as you said, they can come into my 3D space. And so that's been completely, quote, democratized so that that scenario is now available to just about anybody. You don't have to build a custom elevator system or a plumbing system. So you're starting to see this adoption of the commercialization, whether it's in remote assistance like that. We're seeing things like pilot training, which is another scenario because today to get time on one of those big simulators, kind of expensive and hard to do. So most of the simulators that are in place today run 7x24. Yeah, you know, to get an hour in a simulator, you have to find the time and also the cost. But let's say you're a pilot and you're flying, you go into another city and you're going to at subsequent time flying to a new airport and you want to get a sense of the runway layout. You could just do that in your hotel room. Put on the HoloLens, bring in this new airport, it's a little island airport somewhere so that you're interested in where the mountains are.
Even practice landing.
You could. You could actually jump on the bed and jump off the bed in the hotel room.
No, I mean, you know, like
Yes.
flight simulator, right?
Yes. No, absolutely.
Yeah.
Absolutely in that sense. But the notion of being able, and it's not the same as a simulator, it's not exactly the same, but for a pilot who's actually a trained pilot to get a sense of the approach into this little island airport that has a mountain at the end and the sea on either side, you can actually start to do that in sort of fairly interesting ways. So we're seeing sort of applications like that, design applications, designing golf courses and stuff like that. So you're not seeing them in a broad way. And so if you sort of look forward a little bit, there's a hurdle that people have to break through, which is both the equipment that you need to do full mixed reality, the cost of that equipment, and then the right applications in the scenarios. Because we're obviously discovering for people who wear the contained headsets, there's a common scenario with vertigo, which is that if your peripheral vision is blocked, for most people, 20 or 30 minutes, people start getting vertigo because your peripheral vision allows you to stabilize your place.
Yeah.
So maybe they fix that in a new kind of headset. Maybe.
Yeah. Yeah. I know I purchased one of the Microsoft augmented reality headsets,
Right.
and it's pretty interesting actually to play with. You know, I've actually really enjoyed it. There's some great VR style games. The augmented reality in our headsets, just to be clear, isn't like the HoloLens augmented reality where your eyes see what's around you and we put things in your environment, right? It essentially means you can run Windows app in a virtual reality environment.
Exactly.
So I just want to be clear that there are two different types of AR that we're talking about here.
But the HoloLens has what we call mixed reality, which is you're actually looking at real and injecting virtual into the real.
Yeah. Yeah, so I guess augmented reality is all virtual, but you're injecting apps that weren't originally designed to be virtualized.
Correct. Yeah. So I think we've got a place to go in terms of getting broad, commercial consumer adoption.
Yeah. Yeah, cool stuff. So one of the things that you mentioned that actually was a term that I hadn't heard before was the connected cloud stuff we were talking about a little bit.
So if you actually look at where we've come from with clouds, is that there's been these massive data centers, which are a thing of beauty. If you haven't seen one, if anybody gets a chance to see it, it's an amazing thing to see. You walk in, there's hardly any people running it. It's all automated. There's hundreds of thousands of servers in some cases. Just amazing. As an engineering geek, it's just a great thing to see. It's like
probably a Pied Piper box in there somewhere.
Yeah, somewhere. But it's from a geeky perspective, it's like one of those things when you go up to the Boeing factory north up in Everett, from where we are, and you can go through the assembly line. It's like you just watch these things and wonder. And that's what one of these data centers is like. But as we start to build these out, and we've discovered that people are running applications that run in multiple regions and multiple data centers, it turns out that the clouds have to be connected. And the data centers need to be connected in different ways. And so the consequence of that is that there are private networks, dark fiber networks that are built that are connecting these clouds together, because you have to have predictable performance, quality of service, latency management. And so instead of having sort of these disconnected data centers, you've actually got this connected web now, which is there's no sort of central hub, but there's this, everyone's connected to everybody else via some mechanism. That means you can now, if you're so inclined, can build this really ugly large application that runs in multiple places at the same time. So that's the one part. But then the more interesting thing is what I call cloudlets, which is little clouds, because these are all really big clouds, but little clouds are what we are on the edge. So what could be on the edge could be an Azure stack, it could be a couple of servers, could be a Raspberry Pi, and all of those things are connected into one or more clouds or one or more backbones. And you've got the same issue of quality of service and latency that results in different topologies of layout. So if it's an Azure stack that's at the end, which actually is a sort of a medium-sized cloud, if you say, then the connectivity that you get from that would be one kind. But then if I go from that Azure stack and I'm talking to an actually piece of manufacturing equipment on a production line, I might be less dependent on the link, because I want a lot of that AI, much as we said on the drone, to run at the machine, in which case the machine doesn't have to actually have low latency connection, because it's just going to send me messages as things are happening, give me updates as things are happening. I don't really have to be connected to it in real time. And so there's this interesting sort of layered big data center, medium size, super small, teeny tiny in the stack, and the data flow that's out of them. And the consequence is that the more of the core processing that you can move close to the place that it's taking, where it's happening, the less data you have to move. If I could take a video picture, for example, and if I could put the recognition into the camera, that would be one thing. Today, to take a video feed in HD, you need about 17 megabits. But if I can actually do some of that in the camera, could I bring that down to 1 megabit to be able to do that? Or even less, or maybe only send the picture like my webcam at home, it wakes me up and says, hey, something's moving. Here's a picture. You can actually get this much more interesting sense. And so what I love about this sort of topology of nodes is some are hardwired connected. Between data centers is this massive fiber with massive throughput. But the other end of the spectrum is a small thing at the end that is actually mostly disconnected, sometimes connected at some random speed. That topology is the thing that I love about these connected clouds, because it gives, as somebody who does architectures, it gives us this flexibility of how to design things and move things around that we didn't really have before, because before it was either you're going to run in your on-prem data center or you're going to run in the cloud. Now I've got so many choices of placement, and a lot of that comes from the creation of this connected clouds. All the way these big clouds, cloudlets, little raindrops are actually connected in an interesting way.
Raindrops, I love it.
Yeah. Well, they're not really a cloud. They're like little things.
Yeah. No, it makes perfect sense. It's just great terminology.
Yep. But you get the idea of this sort of notion of speed, volume, latency, and the ability to distribute them, because the world we came from with the initial clouds was centralize everything. And you quickly realize that if you can communicate, you don't need to centralize everything. Let me riff on that for a second, because one of the consequences of this web is management and security. And so making sure that the connections are secure, where you've got a secure endpoint, that starts to get really interesting, and the management or visibility into that network. But I can automate that using AI and a bot, so I don't worry about that.
So I wanted to take this opportunity to maybe talk about a term that I think a lot of people have heard, but I don't think really outside of, the technical space a lot of people understand, and that's blockchain.
Yeah. So the first thing I tell people about blockchain is if you want to invest in digital currency, go for it. But I actually have a bridge in Brooklyn that I can sell you that'll probably have better return than blockchain. So digital currency is one thing, and it's the way that blockchain happened, but I don't think it's necessarily, it may or may not do something. But there's so much more that you can solve with a blockchain. And we're actually seeing some very, very interesting real applications being built. And so the essence of a blockchain is when there exists what's called a consortium, which is two or more entities. It could be governments, it could be companies, it could be individuals, but two or more to make the chain, who are actually not affiliated with one another. So if I were to say a company and subsidiary, a blockchain will work, but it actually is not the best place. The best place is when you've got loosely coupled companies. An example would be a supply chain. So you've got a company that actually has a manufacturing facility in Europe that makes, I don't know, chocolate, and that they want to get that chocolate to a particular place. And so they manufacture it, they give it to a trucking company who takes it to the harbor, they put it on a boat, it comes off the boat on the other side, gets on a train, lands up on another truck, gets to a distribution center and lands up in a store, and you go buy your chocolate. So there's probably 6 or 7 independent parties in that consortium. When you're in that consortium and you're getting a handoff, the blockchain provides a perfect way of having transparency and visibility to everybody on the movement of the goods and services and the product as they go through it. There was some stuff that people talk about, which was getting titles on houses and actually doing that, or is this picture real or not? Blockchain works really well with digital assets. So if you've got a video recording or a music recording that you could store on the blockchain, then managing the access to it and everything is really simple, because I actually have the asset as a digital asset. But if I've got, I don't know, a Renoir painting that I'm trying to manage its originality in the blockchain, you have to actually tie the physical painting to the pointer in the blockchain, which means when you turn the picture around, there's a barcode on the back that says this is code number 7. That is the link between the physical and the logical. That's where blockchain breaks down in some cases, because if I replace that Renoir with a copy that's got a copy of the barcode on the back, the blockchain still is perfect, but the actual original has been displaced. And so you see things, for example, on diamonds where they're etching into the diamond, a code is being laser printed into the diamond to give you this sort of rigorous pointer to asset connection. But in the case of chocolate, I'm actually back into that other space, which was I've got a pointer. But that's actually okay in this case, because I'm not worried about authenticity. I'm actually worried more about the tracking of the asset. And so supply chain is we're actually seeing a ton of applications where this happens. There's some great financial service applications. Microsoft actually runs one, which is for letters of credit. Today on inbound letters of credit, it was taking us about 5 weeks to establish a letter of credit with a customer around the world. And typically on a letter of credit, there's a whole bunch of intermediaries. So not only does it take time, but every time somebody touches it, they actually scrape a couple of dollars off the top and then hand it off and then hand it off. And so we built this blockchain with Merrill Lynch Citibank that has two parties in it, us and the bank, and we went from 5 weeks to 3 days. It means that all of the letters of credit have to be funneled through that channel, but I'll buy 3 days to 5 weeks any day. And so that's a very, very simple blockchain application. But I'll give you sort of a geeky application. Let's say you bought a new car and you're running some firmware in your car. Now, if we were having this conversation 5 years ago and you had a firmware update for your car, you'd have to go to the dealer and they'd actually have to reprogram the control unit at the dealer. You had no touch on it. But that's different today. Many cars, BMW does it through a USB. Some cars will do it over the wire, over the air to actually do these upgrades. How do you ensure that the software in the car is actually the software that was accredited and tested at the manufacturer? It's an interesting question because to some degree, somebody could create a virus which gets attached to the new firmware update of your anti-lock brakes. That when your firmware gets updated, it actually gets the virus, and now your brakes may or may not work. So previously, the quality of the software in your car was controlled by the dealership having a certified technician who could do it. But as soon as we break that mold, how do you actually qualify that the surety of the software is the one that the car manufacturer or the brake manufacturer is? We could put that on a blockchain. So we could actually validate the asset on a blockchain to make sure that that's the right asset with the right digital signature that's getting into your car. So that's actually an interesting example because you've got the car manufacturer, I don't know, in Europe or Japan, let's say, who actually is sending those bits to a dealer in the US who's actually giving to you in some mechanism, and those are all contractual consortium relationships. They might have contracts, they might not. That actually is going to take some software that's written at source and going through multiple steps and getting installed on your car. The same thing's true for medical equipment. How do you actually validate software on medical equipment? So the blockchain provides a great way of actually assuring that things are what they claim to be and that they're accredited along the way, particularly when it's a digital asset like software. You can actually do that. So we're starting to see major applications being built by companies to get there. I'll give you one more example that's sort of interesting, which is around digital identity. The identity on the web is sort of interesting, and today, wherever you log in might have single-part authentication, might be two-part authentication, where you've got to log in with a password and then do something on your phone, let's say. That's all stored in a directory like Azure AD and others, but wouldn't a blockchain make an interesting way to actually keep my identity, and therefore I give permission to different systems to say you can access my identity, but you cannot. And in fact, I can turn anybody off at any time. I can say, look, I don't care whether you think you can use my ID, but I'm blocking you, and you can block their access in the blockchain. Right. So you're starting to see some really interesting, fairly deep applications. And at the same time, you'll see lots of people building out their own little digital currency things. And
that's very interesting, but it brings up some concerns, right? We've talked about artificial intelligence. We've talked about augmented reality and mixed reality. And we've talked about the cloud. And there's a lot of data flowing around out there. Some of it is, my data. So what are we doing about privacy and maybe ethics when it comes to handling this stuff?
So I think that if we look forward, this is going to be the premier issue that starts to surface. And if we'd had this discussion 6 months ago, people's responses would be different. But now that we've seen the issue that happened with Cambridge Analytica and Facebook, and then some things that have happened on autonomous cars, suddenly people are much more aware. And so there's some really interesting things about privacy. So you could start off with like access to my data. You talked about your data flowing around. Wouldn't it be great if I had a blockchain and I said you can get this and somebody else can't? Now, I'll give you a real example. Let's say you had a DNA screen done and your DNA analysis was actually stored, decoded, and it was stored somewhere. and then you wanted to selectively provide that data to some people. In other words, let's say there was some family history, let's say of Alzheimer's, and you actually would support Alzheimer's research, you'd give them access. Right. But there'd be some other guys you wouldn't give access, because the last thing you want is somebody taking your DNA, analyzing it, that you have a particular personality trait and that you wouldn't make a good president, and therefore you should never stand for president because you have these crazy tendencies. So your DNA could actually do some things and provide some pointers to people that are kind of private. And so controlling your data is actually one of the really, really important aspects of it. But your data is being traded today without you really knowing. You've actually given your data to lots of people who are selling your data and actually probably selling it back to you for a fee, even though it's your data that you gave to them. And I'll give you an example. I did this thing recently with, I fly a lot, as you know, and typically when I fly, I call up American Express and say, hi, yeah, it's me again, and I'm flying to, I don't know, Colombia, and don't worry, my credit card's good. And they'll come back and say, fine. But then the other day, I got this email from American Express that said, hey, Mr. Judah, nice to have you as a great customer. We really appreciate it. But we noticed that you're going to be doing some international travel. Don't bother calling us. We've got you covered. Now, how do I feel about that? Your point earlier about sharing your data. I mean, how do I feel about that? Well, the one side of it is I'm actually relieved because I'm going to be in these weird countries, and I'm actually kind of relieved that American Express is going to make sure that I don't suffer. Well, that's good. Right. But how did that happen? So what happens is that if I go look at my Amex bill, I'll see, because I used my Amex to buy a Delta ticket, I'll see not only the charge to Delta, but I'll see the Delta itinerary on my Amex statement, which means that Amex is buying my itinerary from Delta. Now, the way they buy it is they probably charge them less of a commission. Instead of charging them 2% commission, they probably charge them 1.5%. So the half a point is the value of my data. And so Delta is selling my data to American Express, who's then providing me value. But I'm like you. I don't remember telling anybody that was okay. Now, it probably did. You and I probably didn't read the 27-page contract on page 42 at the bottom in 4-point font that said, I agree, and you said yes. Or it's a default sign-in and you didn't sort of sign out. So you've actually given up some rights to your data all along, and people are then using that. I'll give you another example. I use Waze to help me drive around town. And in Waze, you do some interesting things. You tell Waze where your home is. You tell them where your work is. Waze knows which restaurants you go to. It probably knows what movies you go see. It knows where your friends are. It knows a whole lot about you. And you give them that data because they give you traffic information. And so there's an exchange of value, except I never remember signing up to saying, I'm going to tell you where I live so you can actually send me spam ads. Right. I tell you where I live because I wanted to constrain where it goes. And so this whole notion of privacy actually is in a broader scope of ethics. And so the way we think about AI is actually responsible AI to augment human capability, to make people better. And when you frame it like that, we've published a book recently called The Future Computed, which you can find on Microsoft's website. You've got ak.ms whack Future Computed. It'll give you a link to the PDF for the book. And it actually states our position around ethics, and it's a principled position. We identify 6 principles. Privacy, fairness are some of them, transparency, reliability. Those are all elements of the ethics of AI. And we've now said this is the position that we take in the market. We won't use your data to do something with it that you don't know about and that you haven't given us permission to. And so we're taking a really strong public stand, not only through the books that we've published in the stand, but also through something called the Partners in AI, which is an open sort of third-party organization that we and some others have signed up to, that actually is, you have to sign up to a manifesto about how you're going to use people's data. And so we're being super visible about the way we think about privacy and ethics of AI. But there's some really interesting things that are the consequence of AI. And so part of the consequence is denial of service. So not in terms of an attack on your network, but when you go to a bank and you apply for a mortgage, somebody's going to decide that you're going to get it and somebody else is not. And that's a great place where I could build an AI model to make that decision. You get it and you don't. That's a denial of service. Right. What we know is that models are created by people, and people are inherently biased. Right. And so if people are biased, the models are biased, the result will be biased. And so left to its own sort of roots, what will happen to a mortgage application system is it'll likely give the mortgage to the person most likely to pay back, who's probably a 42-year-old white guy with 2 kids and 2 jobs. And so the model itself will start to build in bias, and particularly over time, as it starts to learn from what's happening, the models become biased. So there's this notion of denial of service, harm to individuals. We don't want harm. And harm can be both physical harm, but more interesting enough, emotional harm. On the denial of service, let's say there's a new drug come available, and it's in restricted distribution, and you really, really need it. And we run this through some AI system. It says, we love you, but you're not the best candidate, so we're going to give it to somebody else. That's a denial of service, but the emotional stress that you gives to you is sort of daunting. And the final one is on human freedom and making sure that AI systems are built to support human rights and human freedom. And so we've taken this very aggressive stand. And a couple of weeks ago, Eric Horowitz wrote a blog which said, hey, we're taking this position, and we realized that it has commercial impact. And we realized that there are some systems in some places that we will not do. We're not going to do them because we don't believe that they fundamentally fit into our ethics framework. So I've actually talked to customers and partners around the world about this, and it lands remarkably well, particularly driven by the events that have happened. And some of them are because what people do in sort of the models, but some of them are how we design systems. So when you think about safety and reliability, let's say you got an autonomous car. The scenario that actually happened down in Arizona recently, the car was driving along. God knows what the driver was doing. He was probably reading his phone or taking a nap or having a cup of coffee because he wasn't paying attention. And the car noticed that there was a bicycle coming up. And the car sends a message to the driver that says, I think there's something happening. Please take control. Driver's not paying attention, doesn't take control. System sends another message that, please, it really, really, really looks like we're going to hit something. Can you take control? Driver doesn't do something. And we see this in the telemetry that came back. Third time, car like, please, can you take control? Guy doesn't do anything, and the car hits the bicycle. Now, there's an element in there of design because this is an autonomous car that can drive by itself. If the car, after 3 tries, realizes that the driver's not going to do anything and it's going to hit the bicycle, why didn't the car just pull off to the side of the road and say, I give up? I'd rather not hit anybody. So that's a system design. That's designing for reliability. Right. And it's easy after the fact. I'm not knocking the designers by any means. It's easy to say that after the fact, but there's an element of safety and reliability. Back to my earlier comment about probabilities and all of those things, we need to build in these fail-safe things that happen so that the AI system does not actually harm people or cause physical, emotional harm, and that can come through great design and reliability. And so I think if we actually turn this lens around and sort of look forward a couple of years, this ethics topic is going to become the topic of AI.
Because I think so.
There'll be legislation, there'll be government policies, there'll be companies taking positions, there'll be companies doing good things, there'll be companies doing bad things. All of that's going to happen. And so if I think the technology is not going to be the constraint, the thing that's going to be the constraint of AI going forward is this topic. And there are lots of great things AI can do. Predictive maintenance on Rolls-Royce jet engines actually doesn't seem to be an ethical issue for me. But there's also the other end of systems that are bad, which you can identify really quickly. In the middle are where there's this gray area. And that's where I think there's going to be incredible conversation that goes on. And so as much as the AI technology is moving forward and we can have automatic drones taking pictures of bridges and doing things, this is going to be the essence of it. This is, I think, going to determine the adoption and growth of AI because we're seeing AI being infused everywhere. We're seeing it in your phone, in PowerPoint, in networks, in devices, in cars, everything that you're seeing around you. Education is a big one. But in many cases, a lot of the essence that it's going to come down to is going to be the, so what exactly are you doing with my data question? How did this recommendation happen? And so if there's one sort of thing to look forward to a problem that needs to be resolved, this one. It's not a technology question. It actually is an ethical question.
Yeah, and I'm sure Cambridge Analytica wasn't the first company to do the things that they were doing.
No, they were the ones that got the most publicity the quickest.
Right, exactly.
But the interesting thing about Cambridge was that although Cambridge as a company has shut down to actually prevent litigation against them, the guys who really suffered in that case was Facebook. They were the ones in front of various government organizations, both here and in other countries, testifying to what had actually happened. Their share price gets impacted, where they actually were not the ones who actually executed on this, but provided the platform for it to happen. And so the downstream consequence, so if you put that into real terms, which is if you've got a consumer packaged goods company that actually does one of these things and actually impacts some things in a bad way, their brand could really be impacted. The value of their company, their stock price, their balance sheet could really be impacted, and companies could walk away and say, we're not going to deal with you anymore because we didn't like what you did. You did some things with kids, or you did some things with elderly people that we didn't think were very ethical, so we're going to stop. What I love about this was these ethical questions actually existed before. I could have had the same conversation with you about some business intelligence we built on a banking application, for example.
Right.
These are not new. AI has been the catalyst to us having this conversation because of the power of AI and what it can do. That's what's actually triggering this today. So I love this topic. I actually think that this is going to be the turnkey of deciding how well we do this or not.
I think the difference is, as a human being, when you're having those conversations with people, that may or may not get blocked for something, you have the ability to understand what the issue was that's a concern. You can make logical or emotional decisions based on the information that you collect. And I think that's where this model can kind of struggle.
It is. But if you come back to the sort of catchphrase that we use, augmenting human ingenuity. It's actually not making the decision, but augmenting your ability to make an informed decision.
Yeah.
We'll get to closed loop. Closed loop will come, but we've got a lot of things to solve between now and closed loop.
Right, exactly.
Yeah.
Well, Norm, listen, thank you so much for doing this again for us. These are the shows that I look forward to.
It's always fun. I love these things, the random tensions that go down.
Yeah. Are you going to Ready this year?
I will be at Ready in Vegas. I really want to go and spend a week at 110 degrees inside a building in Vegas. It'd be great.
Yeah, I had somebody ask me about that today. They said, are you going to Vegas? And I said, no, I'll probably be going to Seattle, right? Because we're still doing the winter one in Seattle.
We are.
And he said, I wonder why we don't do the winter one in Vegas and the summer one in Seattle. And I said, I bet there's a price difference.
Yeah, that probably is. And July and August is the best time to be in Seattle. I mean, that's recruiting time.
Oh, yeah. It's gorgeous.
It is.
I can see Mount Rainier.
You can. You can.
All right. Well, listen, thank you again so much for doing this. And, I love doing this, and it's certainly fun for us. You said it was fun for you. It's fun for us as well.
No, this is great. And I'll be here next year. We'll actually do the next one. You're number 6, so love to do that.
All right. That's awesome. Well, thanks, Norm. And guys,
Thank you.
that's your taste of Premiere.